I just don't know what I want to do with my life. I mean, I love pre-cal so much. I don't think I want to do anything else.
You know, Elaine, maybe you should take some time and think about it. You know, really think.
Wait, I've got it! I'll be an economist! So here's the deal, Teach. I want a job where I can do pre-cal every day. Wait, who are you again?
Meg Ledyard, lecturer in economics.
Oh yeah, my bad. So you're an economist too, right?
I am an economist.
Wait, what the heck is an economist anyway?
Ooh, so there's the colloquial definition of economist, which tends to relate to anyone who works in the economy. Like on TV, people will talk about themselves as economists, and often that just means they have a job in a corporation where their title is economist, which means they work with the economy. I would say, you know, sort of a real economist, or sort of someone who thinks about the economy sort of more academically, usually has a PhD, does a little more research, things like that.
So I like math, right? On a scale from 1 to 10, how much math is involved?
I would say 10. I mean, it's pretty much an everyday, in your research, every day you're using math of some sort.
Oh, snap. So, like, in your opinion, or whatever, are pre-cal concepts important?
Yes, very much so. I mean, anything you end up doing with the economy, you're going to use some sort of math. So any statistics stuff that you do, any looking at the future, that stuff's all going to be mathematically based. And sort of in terms of, I mean, I don't know what you guys learned in pre-calc this year. But, you know, I use tons of calculus every day. Even if you work in sort of private industry, you're going to end up looking at a lot of stuff that is not necessarily calculus-based, but more functions and sort of learning about functions. And, I mean, that's all that we do pretty much. It's like, if this happens, then what?
Will you do a math problem for me? I love math.
Okay, so let me start with, I don't know if you remember this, but that's okay. So we have two goods, right? We have the X good and the Y good. And we have a budget constraint. So if these are quantities, this budget constraint is going to tell you all of the quantities that you could choose. Like a point on this line says you could choose this much of good X and this much of good Y. Does that make sense? Mm-hmm. So, and then we have these indifference curves. So this is an indifference curve. And this is a budget constraint. An indifference curve tells you something about what people like, so that's preferences. So a lot of times, we'll call this utility, which is a function of the quantity of good X and the quantity of good Y. And a lot of times we'll use log functions for that. And so it looks roughly log-like. You want some of good X and some of good Y. And so this is log QX. You can do log base 10, you can do natural log, it doesn't matter. And then sometimes we'll have a sort of a constant to give us different ratios, sort of how much you like good X to good Y. This is the same as writing it QX to the A times QY to the B. So that's one thing that you guys probably saw some of, is that if you take logs of both sides, then you can write it more like this. Mm-hmm. So if you look at this, what's this indifference curve telling you? It's telling you what quantities of good X and good Y give you the same number here. So if we put this as a constant, say like 10 equals A log QX plus B log QY. So if we have, if we're looking at this indifference curve is going to tell you all the quantities of good X and good Y that give you the same 10 units of utility. So that's, in that sense, that's sort of how we use logs. And then what we'll do is we'll write an equation for this budget constraint. And we'll say we want to make this function, maximize this function, so that it's still within this set. So we say this maximize such that this is satisfied, this budget set is satisfied. And that's sort of how you add the calculus to it. So you start out understanding these really well, and then you can think about sort of how do you maximize stuff. So the nice thing about the log functions, or the reason that we use them, is because this says that I want at least some of this, right? Going to 0 with either of these is really bad. So it gives you a nice mix of sort of how you trade these things off. Usually you want all of all the goods, or at least some of all the goods. And so if you have a lot of good X, you're going to need less of good Y, but you're not willing to give up a lot of good Y because you have too much good X and less good Y. So that's sort of how we get those indifference curves that we work a lot with in intro micro.
Wait, are your ears pierced? Look, or whatever. I need a second opinion. I gotta go. Bye! Hi, I'm Elaine. Who are you?
So my name is Laurent Matteux, and I'm an assistant professor in economics.
So what kind of math do I need to know to be an economist?
So the first type of math is calculus. So, and in my opinion, the reason why it's so important in economics is for maximization. Right? I also use real analysis and probability theory. Now, it's very important. I don't think you can do any kind of technical curriculum without doing calculus. I just cannot conceive of not knowing calculus. It is just so basic, so important in many, many different things. For economics, physics, any kind of science.
I think I'm getting it now. Pre-cal is important for me to understand calculus, and calculus is what I need to be an economist. Wait, is your ear pierced?
Come on, Elaine, which kind of question is this? Wasting my time here.
Bye! Wait, I don't want to be an economist. I think I'm already an astronaut.